So we're talking about outlier models, and we've been covering in the previous videos a number of different outlier models. Those outlier models include using support vector machine if we have a classification model where we already have data that's been labeled as an anomaly or not, fraud or no fraud. We can use multinomial naive Bayes for detecting spam emails, for example. And we can use dbScan for cluster analysis if we don't have labels, because it identifies anything that's flagged as should not be in the group. And in our previous video, we talked about Benford's law or first digit law and use that to identify fraud within financial reporting, because it identifies when numbers don't look natural, when they look like they are made up. In our last video on outlier model, what we're going to do is look at forecasting models. So here, if we're trying to predict a number, an interval, or ratio type data point, what we can do is we can create a forecasting model. We look at over time, and we are identifying what appears out of sorts. Doesn't appear like it should be in the model because it's too extreme. So what we do is we actually fit our forecasting model, our trend, or if we're doing regression, so it's not a time variable but something else, we have another variable or multiple variables that we're fitting in our model. And so this creates this line of best fit. Well, we can then identify anomalies or outliers based on data points that are too far away from that line of best fit or trend or forecasting model. And so what we do is we look at, here is the center where we have our trend line. That is the center. That's where there is no error. The further you are away from that trend line, the more we have measurement error between what it is predicted and what's forecasted. And so that can flag potential anomalies. So we could look, for example, let's say anything that's more than 2 standard deviations away from that trend line, that should be about 5% of your data. That is kind of out of sorts, something we should investigate and look into and see if it is an issue. So you can choose to look at anything outside of 2 standard deviations. So if you're kind of thinking outside of this blue area here, or you could look at anything outside of 3 standard deviations. So we want to make it show ones that are outside of that. With 3 standard deviations, that should be covering 99.7% of the data. So less than 1%. The most extreme values get flagged as potential outliers. So how do we do this? Well, let's take a look at how we do this. We are in our outlier Python workbook. You can access this workbook at drstephpowers.github.io/BIA. And we are here at outlier detection. You can open that workbook and work along with us. Open it in Google Colab, save a copy. And for this particular one that we're doing, what we're going to be using is a data set called runtime. So when you go into that, you click on it, go into GitHub under the data folder and pull the runtime. Load it into your Google Drive somewhere, and then mount your Google Drive so that you can pull up your data sets. And then we'll need to locate where we have stored that. And in my case, I have stored it in a folder called BIBA Handbook, and Chapter 9 is where I can find the runtime. So we will load that in. Now in this particular example, we're going to create a profit model. And that's because in other videos, we've covered all kinds of other forecasting models. So we might as well cover profit in this one, since we didn't cover it in the others, so that you can see all the options. So to do profit is a medium-term forecasting method created by Facebook. And what makes it different from some of the other models like Surima is that it has the seasonality. So it can identify, the different times a year we should get different numbers, but it also allows for there to be differences on weekends, on holidays. The idea was that they were trying to model Facebook posts, and people post at different rates depending on if it's a holiday, a weekend, during the week, certain times a year, and they wanted their model to be able to forecast that and take all those things into consideration. So if you're going to use profit, you probably need to install it, pip install profit, lowercase. And then we're going to do from lowercase profit, import big case profit to get this sucker to run. So we are going to load in profit. And just to take a look at the data set that is the runtime data set, fairly simple. It's just got some timestamps. And then for this particular company, how long different coding things take to run. So we have some runtime here. And we want to plot this information. So if we're going to do just very basic scatter plot, we could use Seaborn and import scatter plot. We've been using that a bunch. And this one I've made the data points kind of big, so we'll run it here, but you'll see they're quite big, so we could get rid of that. So I can import matplotlib as MPL if I do want to make the data points bigger, like we've been doing with cluster and classification. Probably shouldn't, given this number of data points. But we should import matplotlib.pyplot as PLT. So I run that, and you can see my big dots and why that might not be the best thing, because it's just a bunch of scatter everywhere. So maybe we don't need our MPL and our bigger data points. Maybe we just go back to regular size. All right, we're doing scatter plot. On the x-axis is going to be the timestamp, so we call that hour. And on the vertical axis is the runtime. And we can label the x-axis and the y-axis. The x, we're going to remove the tick marks because we don't need it to put every timestamp. It'll just turn out into just be a black blob where all the text and words are on top of each other. So I'm just going to make it disappear by having the plt.x ticks be empty. All right, show me the graph with smaller dots. All right, so here we have our data. And so what we're going to do is we are going to fit a trend line to this. Right now it just looks like a giant mess, but there is actually a pattern to it. It goes up and then down and then up and then down. And so in this case, we want our model to account for that, because the anomalies aren't these extremes that are part of the cycle. So for example, if we were looking at ice cream sales, well, ice cream sales are peaking in the summer and they're low in the winter. We don't want those highs and lows of winter and summer to be marked as anomalies. So we want a model that actually takes that seasonality into consideration before it identifies other things as outliers, which is why here we're using like a profit model. All right, so what we're going to need to do is we're first going to need to make sure that it knows that these here in our hour column are date time stamps. And so we need to specify how that's done. So here we have day, or month, day, year, and then we have hours. So we actually need to say that it's going to be date time, 64, and then hard brackets NS to make sure it recognizes that appropriate timestamp. So we're actually going to take our hours and change the type to be a date time model and not just think it's just numbers. And we'll just go twice to deal with the error there. All right, so then we need to call our model, fit our model, same process we follow all the time. And so here we're going to build a profit model. And this is where we're going to identify what is going to be counting as an anomaly by identifying what kind of confidence interval we want. With the profit model, you can specify, right, 95, 99. And so we're going to look then anything that's outside of that range. So here we'll go with 95% to allow for a bit more conservative, flag more things as being anomalies just to be on the safe side. Okay. You can specify there's a number of different choices in profit. So you can say yearly seasonality, yes. Weekly seasonality, yes. So you can choose, there's even more if you're investigating it further in what terms of what you want to include in your model. All right. Now, the other thing, the weird thing about profit is that you have to have it formatted a certain way to make it work. It's very picky, which means it requires that your table be 2 columns. The first column be the date timestamp, the second column be your values, and they have to have certain names. So the columns actually have to be labeled so that the time one is called DS and the value one is called Y. So we're going to use run.rename to rename the columns in our data set. And all we've done then is created a new table here that looks like this with our new labels. And that's because for whatever reason, this profit one has to have these two column names in order to work. All right, so then we do model.fit, and we simply put in the name of our table, which in this case, since it's runtime, we're going to make it run. All right, now we want to do is we want to use it to predict. Because we're not actually forecasting in this particular case, we're actually going to use it not to forecast forward into the future, but we're going to use it to look at the existing data. So we're actually going to use this model.predict, but on the data that was used to build it. Okay, so that's what's a little different here is rather than forecasting forward into the future, what we're going to do is just simply take that same data and put it into our model.predict. And what this creates for us is a number of different columns. So we have our original information, our date time stamp, and it's going to give you a Y hat lower, Y hat upper. So these are the bounds here in terms of that 95% confidence. Okay. It has all the weekly impact, yearly impact. It has, so it's got a lot of information. But really what we care about is Y hat. So that's going to be the point on the trend line. And then Y hat upper and lower are going to be that range that is the 95% confidence. All right, so we'll just ignore that rest for now. Okay, so we can actually just even simplify this down. We're actually going to take this table, which is what we get from our forecast, and we're actually going to merge it with the table that is just our runtime table, date stamp, and our runtime. So what we're going to do is we're going to say, okay, let's merge the runtime table in its complete form with the forecast table, what you see here, where we're only pulling from the forecast table the date stamp, Y hat lower, and Y hat upper. And when you merge tables, this is like our SQL join, where we are going to say, okay, this table and this other table, what column do they have in common? And in this case, the column they have in common is that date time stamp. And so run has to have a column called DS, and the forecast has to have a column called DS, and they have to contain the same data points so that it can then be merged on that particular one. So when we do that, what it does is it creates a table that is our original table, DS and Y, but it has now added to it Y hat lower, Y hat upper. All right, now we can expand on this table and create another column where we have a label for our anomalies. So what we're going to do here is we're going to this next line of code says let's create a column called anomaly, and we are going to apply, and we're using lambda because we're going to apply it to each row here. And what we want to do is we want it to look at the value of Y. Is it less than Y hat lower? So are we outside of the 95% confidence because we're less than our lower bound? Or is our Y value higher than our Y hat upper, so we're outside of our 95% confidence interval and we're more extreme? So if that's the case, if we have one of those, then we are going to give it the label 1 for being an anomaly. Otherwise, it's going to be a 0. And this apply here, we're applying it to each row, and we use that lambda command to help us make those applications to each one. All right, so this creates this new column called anomaly, and then we're going to have it sort this whole table here where to give us those anomalies that are equal to, so we're going to sort by the date time stamp, so we have it ordered by time and not ordered by here's the anomalies, here's the not anomalies. All right. Run that so you can see it again. So it's not ordered by anomaly, it's ordered still by the time date stamp, so but we can see the markers here. Now, ultimately, we want to plot this information. We could collect, and now we could go back if there is a greater table with more information about this event. We could go back and see what happened here. Maybe this is a particular customer, particular employee, and we could investigate the ones marked anomaly. We can also show it visually on a graph. And so we can color code, and you can pick what color you want. But we can do a nice graph here by attaching a color to this label. So if we have an anomaly, we'll make it one color, we'll make it red, signal an issue. And if it's not an anomaly, so anomaly is 0, then it will be green. So we're just adding a column here with the color code. And now when we go to build the graph, it's already built in. We can also have it marked if you want. You could have a column that gives a label that says anomaly within confidence interval. You could add that too. That's not really necessary here. What we do want is a graph. And so we're going to use plotly.graph objects as Go. So first we'll need plotly express as px and plotly.graph underscore objects as Go. We're creating a Go figure. And we'll first create this empty spot for this figure, and then we'll add components to it. So we can specify the size of the graph, the title. We can specify here the x-axis, y-axis titles. And then we can add our trace lines to it. What we're going to do is we're going to add the red colored dots that are going to be our anomaly. And so we're going to take the column from the performance, that is the DS, and the Y. So we essentially what we want to do is we want to take all of our data, we want to put our trend line on it, and then we want to color code the red dots that are outside of those 2 standard deviations. So we are merging here a number of different graphs together, which is why we're using this particular format. So we have our scatter plots here. And we have our Ys, we have our Y hats. I'll show you what it's creating. So let's just run this. We can come back to it. So what we have here is in black, this is the forecasting model. And you can see how the forecasting model is allowing for that weekly variability and that seasonal variability. That's this black here. And then all the data points in green are the ones that are fine, and then the ones that are in red are the ones that are potentially anomalies. And because it's a Plotly Go, it's interactive, so technically you can hover over it and get information about it. So when we go back to the code itself, what we see in the black is going to be our Y hat over our timestamp. So that's going to give us the fitted model, right? So it's going to be a line in black, and that's the fitted model that you see here from Profit. And what we have in this particular case in the coloring, see where it says marker underscore color performance dot color? That's because we created this new column where we have performance is the name of the table, column is the color is the name of the column. And because we made the labels here inside the table, we can use this command here, performance.color, where the marker underscore color is equal to that. So it pulls, when it puts each data point on the table or on the graph, it can pull that information directly from the table. So that's the added value of adding that column there. In terms of the formatting. We can use other methods, right, where we have, where we specify the color scheme, and then we specify what it's based on, but it's not as kind of clear and cut into this 2 red and green system as simply just creating that separate column. So that's why we have that there. So we can then, we have our model to look at, in this particular case, how long it takes for code to run. It has that variability that we're okay with, but then we can flag ones that are potential anomalies and then further investigate what's happening there. Is it an error in the code entry? Is there actually a problem that's happening with that particular employee or customer or whatever the data is about?